Hello, good morning, everyone. Today we solve a problem number 1665. Uh, Minimum initial energy to finish task. This is the problem name. First, we understand the problem. Then we think a solution. First, we have a array like task array in which we have a one actual and one minimum number. You can see uh, in the task array, uh, we have a we have a one uh, one and two. Uh, this is the actual energy, and that is the minimum energy to start task. Uh, uh, in this problem, one is a like a actual energy to finish their task, and two is a what is the energy to require the start task. If we have a in that 10 and 12, if we energy have a 11, then we can't start the task because the minimum required energy is the 12. That's why we can't start that task. We have to required minimum start the task for minimum required energy is 13 or 14. If we have less than 12, then we can't start that task because we require the minimum energy is the 12. Then we have to return the minimum initial amount of the energy we need to finish all the tasks. Like that, in this example, we have a like 1 and 2, then 2 and 4, and then we have a 4 and 8. This like we can see we require the minimum energy to perform all the tasks. Like first we have to start. If we take minimum energy 4, then we can perform the task because we have minimum energy equal to the 4. We start the task and then we perform, and remaining is the 2. Then we have remaining energy is the 2. Then we also perform that task, but we can't perform that task because the way we have minimum energy is the 8, but we have actual energy is the equal to 2. That's why we require the minimum energy 8, like we see in the example. Uh, 8, then we perform these tasks, and then actual energy is minus from the our actual energy, then remaining energy is the 4. Then we perform the task, second task, uh, that actual energy is the 2, then remaining energy is the 2. Then after that we finally perform the first task. Then after that we can easily perform all the three tasks is 1, 2, 3. uh, if we have a 9 and 10, then in all the cases like greater than 8, we can easily perform all the tasks. But if we have a 7, then we can't perform this task. Like we have to return the minimum energy. In this example also you can see, uh, we have mm, 32. Then we perform the first task. Then we remaining 31. Then we perform the second task, uh, a- and then we have 29. Then we perform the third task. Then we have the remaining energy is 19. Then we perform the fourth task. Then we perform the fifth task. Remaining energy is 9. Then we have a remaining energy is 1. We can say we have written the minimum output 32. Sa- like same the third example. In this problem, we can solve using the uh, uh, binary search, um, binary search algorithm, because if we can see say if we have a like energy 0 to 100, like we have task like 2 and minimum energy 5, and then we have one task is a actual energy is 5, then but minimum required energy is 100. Then if we perform like first we can perform the second task, then our we can start the task and then perform, then we minus the 100 minus 2, that is 98. Then we can't start the second task because the initial requirement of the starting task is required 100, but we have a 80, a 98. Then we can't start the second task. In this problem, we can see we have to maintain the right order. If we can perform the second task first, like if we have a 100 energy, then perform the first task, then the remaining energy is 95. Uh, then we easily can perform the first task. Uh, we can see we have to first of all make the first order. Then we make a one binary search from start to end. Uh, and then search a minimum element. For that, we can perform the all the tasks are given in there, like 1, 2, 3, 4, 5, 6. We can see the solution uh, uh, like that. In this solution, I make a one binary search for that. First of all, I can sort because the we can maintain a order of the array. If we can't order, then we cannot easily return the minimum requirement. Like I can start with a lowest int low equal to 1, then highest value is 189. uh, then I perform a binary search. Binary search is we know we can perform find out the middle element. Then we search for if middle element is required element is less than. Then we go to the uh, uh, low low to mid. If we have a greater than target value is greater than the mid, then we search to the mid to the high. I can make one mid case for that. And first of all, I perform the one sort function. Then I perform a make a one mid function. Then I perform low. If we make a one loop for that, if while loop that perform if our element is lower than high less than higher, then we perform equal to and less than the higher, then we perform the while loop and search for the mid element. And mid element if greater than the uh, uh, target value is the greater than mid, then we search for the mid to high. And if it is a lower, then we perform the first uh, uh, low to mid, like that. Uh, and then we can easily find out a uh, mid element that is equal to target, and that is the answer element, and we return that minimum element to the our answer, and we can find out the our answer. Uh, And in this, I also make a one function for find out the uh, that element. Like first of all, we actual make a actual element actual equal to task 0, and the minimum is task 1. If current less than the minimum, then return false. If it is equal to, then we store the actual into the current n minus 1. Also make a one function for the sort, like sort in the order, like from the uh, like from higher to lower. like that. Uh, I That is the code for the our program. I We can easily submit the code. That it is the code I can write in the Git code. We can run that code. Okay, we can see our all the test cases is passed. Submit that. Okay, our uh, code is the passes all the test cases, uh, and it is a time complexity is a n log n. Because we have a make a one binary search algorithm and sorting algorithm uh, that one required the n log n plus n log n plus log n is equal to n log n. That is the time complexity. Space complexity is we can't store any extra space. That's why it's a big of one. Thank you for watching my video. If you like my uh, content and like my uh, uh, problem solving skills, then you can subscribe my channel. I can upload a daily LeetCode problem. Uh, Thank you for watching.